Hello, dear students. Let's solve a question asked in GATE 2007 on Huffman coding. We are given six letters A, B, C, D, E, F with their probability of occurring. Now, please try to understand in the videos that I explained you about Huffman coding. I had taken frequencies like 50, 30, and all that. Here, probability is given. This is same as frequency. What they are saying is probability of A occurring in a message is 1 by 2. That is, it is 0.5. That is 50%. 50% of the times A occurs. That means probability with which A occurs, frequency with which A occurs is maximum. Similarly, probability of B is 1 by 4. That is 0.25. That is 25% of the times in the entire message B occurs. And the least you can see is E and F. E and F occurs very less times because their probability is very low. So these probabilities have been given and they are asking which out of these options A, B, C, D are the correct Huffman codes for A, B, C, D, E, F. And I'll disclose the answer. A is the answer. Because when you build the Huffman tree, I'll better write the probabilities and build the Huffman tree. Just check. The probabilities given to us are 1 by 2, this is probability of A, 1 by 4, probability of B, 1 by 8, C, 1 by 16 is for D, 1 by 32 and 1 by 32, both is for E and F. Now you will obviously, you know Huffman's algorithm. Out of all the probabilities or frequencies, you will take two least frequencies and join them and add these two frequencies in their parent. 1 by 32 plus 1 by 32 is going to give us 2 by 32, which is 1 by 16. Now you know you have got 1 by 2, this frequency, 1 by 4 for B, 1 by 8 for C, 1 by 16 for D, and this 1 by 16 is there now, isn't it? So you are left out with 5 frequencies or probabilities. Initially you had 6 probabilities. And you know Huffman algorithm, join two least probabilities again. Obviously, least are 1 by 16. Yeah, 1 by 8 is greater than 1 by 16, isn't it? So you will join two least frequencies. 1 by 16 joined with 1 by 16 is going to give you 2 by 16, which is 1 by 8. So needless to explain now, two least frequencies 1 by 8 and 1 by 8 joined will give you 1 by 4. 1 by 4 and 1 by 4 joined and added will give you 1 by 2. Isn't it so? And finally, 1 by 2, that is 0.5, joined with this 1 by 2 is going to give you 1. And obviously, addition of all frequencies have to be 1. And now Huffman says, once you get the tree, label all left branches as 0. All these left branches are labeled as 0 and right branches are labeled as 1. Now, how will you get code for A? The code for this letter A is nothing but 0. Check this. Because from root, to reach A, you just need this edge, and on this edge, 0 is written. So code for A is 0. There itself, you get the option A. Because in no other option, the code for A has been written as 0. But confirm it, that code for B you will get. Code for this letter, whose probability is 1 by 4, you will get if you take this edge, correct, and reach 1 by 2, and then finally take this left edge. So the bits that you have read are 1 followed by 0. So code for B is going to be 1 0. So option A is matching. So A is the answer for this particular question. Now there was a linked question asked on this problem. What is the average length? What is the average length of the correct answer in the previous question? Now for our reference, I will write the codes for A, B, C, D, E, F again over here. The codes are 0, 1, 0, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, 1, 0, and 5 times 1. 5 times 1. Now that means the number of bits needed for A are 1, for B 2 bits are needed, for C 3 bits, D requires 4 bits, and E and F requires 5 bits each. Now it is so easy to get mistaken, you are asked average length over here. So what you might do is you will add all these bits. Total number of bits needed are 20 if you add all this. And then 6 letters are there. So you will divide this with 6. Because number of letters are 6, you want to find out the average. And this will amount to 3 point something. 3 point something. But 3 point something is not the answer given in A, B, C, D. 3 is the answer, but 3 point is not the answer. Well, we went wrong because we did not find average properly. Agreed that the number of bits are 20 and number of characters are 6, A to F, but all characters are not equally probable. Please listen to this very carefully. You find average as 20 by 6 only if all characters are equally probable. But now the probability of A is highest. It will occur maximum number of times in the message. So the method to find out the average is respect the probabilities. All probabilities are not equal. So how many bits are needed for A? 1 bit. But what is its probability? 1 by 2. So multiply this number of bits with 1 by 2. Add it with what are the number of bits needed for B? 2 bits. But what is its probability that it will occur? 1 by 4. Then C has 3 bits. You see 110, but probability is 1 by 8. Similarly, 4 bits needed for D, probability is 1 by 16. 5 bits needed for E, probability is 1 by 32. And finally, 5 bits again needed for F, and probability is 1 by 32. If you compute this value, it will come out as D option, 1.9375. I repeat, you just can't add all the bits and divide that 20 by 6. Because if you are adding like that, 20 by 6, then you know what you are doing. You are saying A requires 1 bit, correct? B requires 2 bits, C requires 3 bits, D requires 4 bits, and E and F requires 5 bits. You added all this and you divided it with 6. What that means you are saying is probability of each letter is 1 by 6. Probability of each letter is 1 by 6. Come on, please try to understand this. Probability of each letter is 1 by 6. And then if 1 by 6 is added 6 times, you get probability 1. But all the characters are not equally probable. How can you divide this sum with 6? By dividing it with 6, you are saying that probability of all the characters is 1 by 6. That itself is wrong formula for average, isn't it? Hence, average has been found by taking the probabilities into consideration, and the answer is D. I hope you have understood this. Now watch, there was one more question asked in GATE 2017. We have 5 characters now, P, Q, R, S, T, and probability of these characters has been shown. But these probabilities are not in correct sequence, increasing order. So it's better we write from largest to smallest. Q has 0.34, correct? Largest. Then next I think is P, 0.22. Then next comes S, I think, 0.19. Then comes R, 0.17. And finally comes T, 0.08. Now these probabilities, the two least probabilities should be joined. This is going to give you the sum 0.25 if I am not wrong. Now you watch, you have got probability 0.34, probability 0.22, then 0.19 and 0. And remember, Huffman says join two least frequencies always. So the two least frequencies over here is P and S, correct or not? That is what you are going to join. 0.22 and 0.19. If these two are joined, you are going to get the sum over here. If I am not wrong, this will be 0.41. Now there are three frequencies, 0.34, 0.41 and 0.25. Obviously 0.34 and 0.25 are the two least. So I'll just manage this. I'll take this Q over here so that the tree looks better. This is where Q is, Q is 34. So 0.34 and 0.25 are the least. So I'll join these two and the sum will be 0.59, isn't it? And finally 0.41 is joined with 0.59. Sum of the probabilities is 1. Now finally you label all left branches with 0 and right branches with 1. Right branches with 1. This is also one of the edges. Left is 0 and right is 1. So what is the code for P you got? Code for P is 0, 0. Check the tree. Code for P you got is 0, 0. Code for Q. Observe where is Q. Oh, Q is over here. Check this. Check the tree. So the code for Q is 1, 0, isn't it? 1, 0. Code for R is 1, 1, 0. check it on your own. Code for S is 01 and code for T is 111 triple one. Okay, so these are the codes. Now the question asked is a message of 100 characters over X, that means over this alphabet set. Message of 100 characters is encoded using Huffman coding. That means now we are going to code PQRST using these codes. But the number of characters in the message is 100. The expected length of the encoded message in bits is. Coming back to the same question that we solved earlier, isn't it? Average length, expected length, but this time expected length of 100 characters is asked. Now, if you watch, P takes 2 bits, Q takes 2 bits, R takes 3 bits, S takes 2 bits, and T takes 3 bits. Isn't it so? But then, what you will have to do is you will have to find out the expected length, isn't it? So if you check what is the average over here, average of PQRST, then P must be multiplied with the probability of this 0.22 into 2 and then add it to probability of Q. Probability of Q is 0.34 and then multiplied with 2 added with probability of R is 0.17. I'll write 0.17 and then multiplied with 3. Probability of S is 0.19 and multiplied with 2 and probability of T is 0.08, 0.08 and then multiplied with 3. If you calculate this will come out as 2.25. 2.25. So this is the average length of PQRST taken one character at a time. But there are 100 characters, isn't it? Then 2.25 into 100, 225 is the answer. What I mean by 2.25, the answer we got for this, what I mean by this is that if you take one of these characters, PQRST, then the average length is 2.25. But you have got 100 such characters, then the average length is going to be 225. This was the question asked in GATE 2017. I hope you have understood it. Thank you very much.